Hello, welcome to today's video. In this class I will talk about matrix. Now, what is a matrix? A matrix is a rectangular array of numbers enclosed in a squared bracket. A matrix contains rows and columns, and matrices are denoted by capital letters. For example, I have a matrix A. It is equal to, this is a square bracket, and we have elements inside the square bracket. Now this is a matrix. All right, so it is a rectangular array of numbers or elements in a squared bracket, and we use capital letters to represent a matrix. Now, I want us to note a very important characteristics of matrix. Now, this diagonal here is called the leading diagonal. It's called the leading diagonal elements. Leading diagonal. Why? This is the non-leading diagonal. Very important. Now also, I want us to note that a matrix has a row and a column. Very, very important. Now, for this matrix you're seeing on your screen, it has a row and a column. Now, A and C is the first row, and B and D is the second row. So, a matrix has a row. Here we have two rows. So, this is the row, is 2, and it has two columns. A, B is one of the rows, C, D is one of the rows. So, we have two rows in this matrix. Good. So when we are to name a matrix can be named by using the formats row by column. So in the case of this matrix A, we can say that matrix A is what? A 2 by 2 matrix. It's a 2 by 2 matrix. Now the first 2 represents the number of rows, which is 1, 2, and the second 2 represents the number of columns, which is 1, 2. So that is an example of a matrix. I can give us another example. For example, I have matrix B is equal to, let's say we have A, B, and C, and here we have D, E, and F. Now this matrix has 3 columns, which are 1, 2, and 3. So the columns, or the number of columns in this matrix, is 3, while the number of rows in this matrix is 2. So this matrix has 2 rows. So if I am to name this matrix, it can be B equal to 2 by 3. 2 by 3. Okay, so these are ways that we can name a matrix. It is named in the order of row by column. So the rows come first, by the columns comes next. So 2 represents the number of rows in matrix B, and 3 represents the number of rows in matrix. 3 represents the number of columns in matrix B. Okay, now we can also have a next matrix. For example, let's say I have just an element in a matrix. Now this matrix can be called a 1 by 1 matrix because it has just one row and one column. So this is a matrix. Okay, now let's look at some types of matrix. Let's look at types of matrix. Types of matrix. The first type of matrix I'll be showing us is called the column matrix. Number one, I'm showing us the column matrix. Now, what is a column matrix? A column matrix is a matrix that has a single vertical array of numbers. When a matrix has a single vertical array of numbers, it is referred to as a column matrix. For example, if I have matrix A and it's equal to, for example, we have A and B. For example, I'm just using letters now. Now, this is an example of a column matrix because it has a single vertical array of numbers. All right, so when a matrix has just a single column alone, it is called a column matrix. Or we can say that when a matrix has just one column, it is called a single matrix. In this case, I can say that matrix A is equal to what? 2 by 1, because we have two rows, which is 1 and 2, but we have one column. So when a matrix has a single column, or when the number of columns in a matrix is equal to 1, we say that it is a column matrix. Let's look at a next example of a matrix. Let's look at the row matrix. Number 2, row matrix. Now, what is a row matrix? A row matrix is similar to a column matrix. Now, when we have a single horizontal array of numbers, that is referred to as a row matrix. For example, if I have matrix A again, this time is equal to, let's say we have A and B. Now what you are seeing here is a row matrix. It has, as you can see, it has just a single row, but it has two columns. So matrix A in this case can be named as 1 by 2. 1 represents the number of rows, which is 1, while 2 represents the number of columns, which is 1, 2. So when a matrix has a single row, that matrix is called a row matrix. All right, let's look at another type of matrix. Now, the reason why we are trying to explain these different types of matrix is because when we start looking at questions, we might need to refer to these types of matrix to be able to understand some very important questions. Now, what is a squared matrix? A squared matrix has the same number of rows and columns. For example, look at this example. Let me say I have matrix A again. This time is equal to, this is A, this is B, this is C, this is D. Now, this is a squared matrix. Why is it a square matrix? Because I have 1, 2, I have 2 rows, and I have 1, 2, I have 2 columns. So matrix A can be equal to 2 by 2. This means that 2 represents, the first 2 represents the number of rows, and the second 2 represents the number of columns. Now, because the number of rows and columns are the same, it is called a squared matrix. So a 2 by 2 matrix is a squared matrix. Let me give us another example of a squared matrix. For example, let me use B. I have a matrix in this form. I have A, B, C. Let me use D, E, and F. I use G, H, and I. Now, here is another example of a square matrix. As you can see, we have 1, 1, 2, 3. We have 3 rows. Number of rows is 3. Then number of columns, we have 1, 2, and 3. We have 3 columns in this matrix. So I can write matrix B as matrix B is equal to 3 by 3. Now, the first 3 represents the number of rows in matrix B, and the second 3 represents the number of columns in matrix B. Now, because the number of rows and number of columns in matrix B are the same, we say that matrix B is a squared matrix. So we are saying that a 2 by 2 and a 3 by 3 matrices are examples of squared matrix. Let's look at another example of a matrix. For example, we have a null matrix. Number 4 is called a null matrix. Now, what is a null matrix? A null matrix is a matrix in which all the elements in that matrix are 0. For example, I have a matrix A again. This time, the element inside matrix A is all 0. For example, 0, 0, 0, and 0. Now, this is an example of a null matrix, or it's called a zero matrix. It can also be called a zero matrix. Now, when all the elements in a matrix are 0, it is called a zero matrix. Very, very important. I will show us one more or two more examples of a matrix or types of matrix. Number 5, we have what we call the diagonal matrix. Diagonal matrix. Now, before I explain this matrix, I will draw a diagram to explain this. Now, look at this diagram very closely. For example, let me use matrix B this time. A B matrix having elements as follows. Let me use numbers in this case. Now, what you are seeing on your screen is an example of a diagonal matrix. Now, what are diagonal matrices? A diagonal matrix is a squared matrix. As you can see, it's a squared matrix because it has 2 rows and 2 columns. Good. Now, a diagonal matrix is a squared matrix in which all the elements in that matrix are 0, except for the what? For the leading diagonal. In a diagonal matrix, the leading diagonal matrix or the numbers in the leading diagonal are not 0. For example, this is our leading diagonal. This is the leading diagonal. Remember that a matrix is a rectangular array of numbers. So that is our leading diagonal. And we are saying that in a diagonal matrix, the leading or the elements or numbers in the leading diagonal are not 0. Okay, Very, very important. We have to note this. It's a very important concept in matrix, that the leading diagonal are not zero. That means that all other elements in this matrix are zero, but the elements or the numbers in this leading diagonal are not zero. I'll show us another example. Let me use C. Here is another example of a diagonal matrix. Let me use numbers again. I have -2 here, I have 0, I have 0 here, 0. Let's say I have, yes, let me call this place 1, 0, 0, 0, here's 4. Now here is a 3 by 3 matrix. You must remember that a diagonal matrix is first a squared matrix, which means that it has equal number of rows and columns. Now, matrix C you are seeing on your screen is a diagonal matrix because the leading diagonal is not 0. The leading diagonal is not 0. This is the leading diagonal. So, in a diagonal matrix, the leading diagonal are not 0, which means that all other elements in the matrix are 0, but the leading diagonal are not 0. So I can write this are not 0, not equal to 0. All right, so that is for the diagonal matrix. I'll show us another or one more example or type of a matrix. Is called the unit matrix. This should be our number 6. Yes, this is called the unit matrix. All right, before I explain this, I have to also draw a diagram to buttress the point I'm about to make. Now, a unit matrix can be written in this form. Let me use D as my matrix. For example, I have a matrix D, and inside matrix D we have 1, 0, 0, and 1. Let me give us another example. Let me say I have matrix E is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, what you are seeing on your screen are two examples of a unit matrix. Now, what are unit matrices? A unit matrix is a matrix in which the elements in the leading diagonal are equal to 1. In this case, we are saying that all other elements are 0, but the element in the leading diagonal are 1. So that is a unit matrix in which the leading diagonals are equal to 1. That is an example of a unit matrix. The leading diagonals are equal to 1. As you can see again, it's also a squared matrix. It has 2 columns and 2 rows. Now, matrix E is also a squared matrix. That's the first thing you must note, because it has 1, 2, 3 columns, 1, 2, 3 rows. Now, if you look at the leading diagonal, right here is our leading diagonal. It is equal to 1. We have 1, 1, 1 all through. This is the leading diagonal of this unit matrix. Is equal to 1. So what we are saying is that a unit matrix has a leading diagonal of 1, which means that all other elements in a unit matrix are 0, but the elements on the leading diagonal are equal to 1. So these are the types of matrix. We shall look at how to use operations in matrix in our next video. Thank you.